In this session, let's focus on a question from Special Theory of Relativity which was asked in CSIR NET December 2024. Here we have an elementary particle which is created in the upper atmosphere and it then moves to downward with speed equal to 0.9999 c, and its lifetime in its rest frame is 2 into 10 raised to minus 6. So after some time it decays here and the lifetime is given to be tau is equal to 2 into 10 raised to minus 6 second. Now the question here is this lifetime given, is it proper lifetime or improper lifetime? How can one decide if the lifetime given is proper lifetime or improper lifetime? For this we can use the definitions of proper lifetime and improper lifetime. So proper time interval, if two events happening at the same place, time interval between them measured in the same frame, then it is called proper time interval. Improper time interval, two events happening in different places. So the key word here is same place and different place. Two events are occurring at same place, it is called proper time interval, and if it is at different places, then it is called improper time interval. Over here we have the lifetime in particles rest frame, which means the event of creation of the particle and the event of decaying of the particle both occurs at the same place because we are looking from the frame of reference of particle. Therefore the given lifetime is proper lifetime. Now if an observer is looking from the earth, then this events, the creation of the particle, it is in the upper atmosphere, and the decay of the particle is not in the upper atmosphere, it has come downward, the particle has come downward. So this is occurring at these events are occurring at different places. So that time interval is, the time interval in Earth's rest frame is improper time interval, improper lifetime. And the relation between proper lifetime and improper lifetime is t is equal to tau divided by root of 1 minus v square divided by c square. Here tau is the proper lifetime and t is the improper lifetime. Therefore we have improper time interval t is equal to tau is 2 into 10 raised to minus 6 second divided by under root 1 minus v square is 0.9999 c square divided by c square. This is equal to, if you evaluate this, you will find 1.414 into 10 raised to minus 4 seconds. Now the question is to calculate the distance traveled by the elementary particle before it decays. So distance is equal to, and that too in Earth's frame. So distance is equal to, distance in Earth's frame is equal to speed times time in Earth's frame, which is t. So this is equal to 0.9999 c times t in Earth's frame is 1.414 into 10 raised to minus 4 second. This is equal to, c is 3 into 10 raised to 8 meter per second. So if you put that as well, then you will get distance in Earth's frame is equal to 42,415.7, and this can be approximated to meters, approximated to 42 kilometers. Therefore, the correct option here is option 2. Thank you for being here, guys. Solve as much questions as you can and let's crack this exam together. Thank you.